In this video, we want to look at some calculations involving sound energy. Now let's look at the first example that we have over here. So the question reads, the velocity of sound in steel is 500 meters per second. If the wavelength of the sound is 0.2 meters, we are to calculate its frequency. Okay, now this is very easy to do. So let's look at the solution to this problem. So the first thing I will do is to write down the parameters. So the question says that I have a velocity of a sound in steel to be 500 meters per second. So which means my velocity V is equal to 500 meters per second. Now I was told that if the wavelength of the sound is 0.2 meters, so the wavelength, or which we represent by this, is equal to what? 0.2 meters. The question is demanding that I calculate the frequency for this particular sound. All right, so in waves, okay, in waves, to find the velocity, okay, or in waves, velocity is equal to the product of the frequency multiplied by the wavelength. So I'll take that again. In waves, velocity is equal to frequency in hertz, okay, multiplied by wavelength in meters, okay, and then the velocity itself is in meters per second, right? So this is the formula. Velocity is equal to frequency multiplied by wavelength. Note that the frequency it is in hertz, and then the wavelength is in meters. So if you are given in any other units, convert it, and then the velocity should also be in meters per second. All right, so now that we know this, and we know that this is our formula, we just need to do some change of subject to make our wave frequency the subject. So to do that, let me use a different color. So to do that, if velocity is equal to frequency multiplied by wavelength, and we want the frequency, we just need to divide both sides by the wavelength. Then they cancel each other out. So therefore, our frequency is equal to the velocity divided by the wavelength. And this will be equal to, our velocity given to us over here is 500 meters per second. And then our wavelength is 0.2 meters. Already the meters over here will cancel this, so we are left with per second as our answer, or the unit for our answer, and then per second is hertz. Okay, now 500 divided by 0.2 will give me 2,500. So I have 2,500, okay, either per second as my answer or 2,500 hertz as your answer. Any of this is correct, as that is the unit for frequency. All right, so let's have a look at another question. Question number 2. A wave of frequency 1000 hertz has a wavelength of 5 centimeters. We are to calculate the velocity of the wave. This is also very simple. So we write down our solution. As always, the first thing I will do is to write down the parameters that I have and then what I am asked to find. So we're told that the wave has a frequency f, which is equal to 1000 hertz, and then has a wavelength of 5 centimeters. And then the question says we are to find the frequency. We have to calculate the velocity, which we do not know. Now, if you look at this, you realize that the frequency has the right unit, but the wavelength is given to you in centimeters instead of meters. So you need to do the conversion. Now, to do the conversion from centimeters, we move to decimeters to meters, and the gap from centimeter to decimeter is 10. From decimeter to meters is also 10. So from here to here is 10. From here to here as well is 10. So to move from centimeters all the way to meters, it's 100, right? Because you are jumping 1. So it means that we have to divide the 5 by 100 to get it in meters. So if I do that, my wavelength will now be 5 divided by 100, and this will give me 0.05 meters as my wavelength in meters. So from here, I can go ahead and quote the formula. Velocity or speed is equal to the frequency multiplied by the wavelength, and this will give me my frequency. It's 1000 multiplied by 0.05, which is my wavelength. And if you compute this into your calculator, 1000 multiplied by 0.05 will give me 50 meters per second as my answer for this particular question. All right, so let's have a look at one last example. So we have the wave generated by a radio station transmitting at a frequency of 100 megahertz. 100 megahertz has wavelength of 3 meters. We have to calculate the velocity of the wave. All right, so let's write down the parameters that we have. So we're told that we have a frequency of 100 megahertz and then a wavelength of 3 meters, and we're asked to find the velocity, which we do not know. Now if you look through all this, you realize that our frequency is in megahertz instead of hertz, so we need to do something about it. And then our wavelength is in meters, which is correct, so we leave it like that. Now in maths, or in anything that you do in math or any other calculation subjects, mega, capital M, is the prefix of times 10 raised to the power 6. Okay, this is what mega means. So it means that our frequency over here is 100 times 10 raised to the power 6 hertz, and then our wavelength is 3 meters. Okay, so therefore, to calculate our velocity is equal to the product of the frequency and the wavelength, and then this will be equal to the frequency is 100 multiplied by 10 raised to the power 6 multiplied by 3 as our wavelength. So if I do this, this will give me 3 times 10 raised to the power 8 meters per second as my answer for the velocity. So this is how we solve problems on sound energy when specifically we are being asked to find either frequency, velocity, or wavelength. Okay, so this is the relationship between frequency, wavelength, and velocity. So velocity is directly proportional to the frequency and the wavelength. Okay, so thank you so much for watching, and I will see you in the next video. And don't forget to like, subscribe, and then also share with your colleagues or friends. Bye bye.